So we're going to work through a task called growing dots, and this is the image that we're given. This is all we know is that there's these three different pictures. We have the beginning, we have after 1 minute, and we have after 2 minutes. And our goal is to create our thinking or represent our thinking on this picture that we're given. We need to represent our thinking in words. We need to represent our thinking in a table, in a graph, and then our ultimate goal is to create an equation or multiple equations that represent our thinking on these pictures. We're also given the information that the pattern that we see or the growth that we see happening is going to be consistent as we move to minute 3, minute 4, and so on. So what I like to do is have some colors to document my thinking. So I'm going to show you two different ways of looking at this picture and documenting the growth that we see happening. So the first thing I'm going to do is I'm going to label this as my beginning dot, my center dot. And I'm going to say that I see that center dot all the way through, remaining consistent. And then the difference that I see between the beginning and minute 1 is that I have this new box of 4 dots that have created a square around it. And then at 2 minutes, I still see that blue box with those 4 dots that have been added. But the difference between minute 1 and minute 2 is that now I have a second square that has been added around the outside. So if I wanted to draw myself a new picture of what 3 minutes would look like, I'm going to still have my center dot. I'm going to have this first box around the outside that was blue. I'm going to have my second box. Pardon me. My second box around the outside. And then, since my pattern is continuing, I'm going to have a third box around the outside. And I realize that is massively larger, but I'm not an artist. So there is my purple circle in the center to represent this beginning dot that has carried all the way through. Here is my blue box that added after 1 minute. My pink box that got added at 2 minutes. And then my third minute is going to have this new box of green dots. So this will be 3 minutes. So if I was going to write this in words, what I would say is there is a center dot that gets a box, so to speak, a box of dots, and there's 4 that gets added each minute. You could say that there's a center dot that has 4 dots in the shape of a square added around it each minute. That would be another way to verbalize my thinking with this picture. Another thing I'm going to say is that my center dot, this is like an addition to it. My center dot has squares of 4 dots so those 4 dots are surrounding my center dot, And the number of surrounding squares is the number of minutes. So if I look back at 1 minute, it's my beginning dot with one surrounding square of dots. 2 minutes is my center dot with two surrounding squares of those 4 dots. 3 minutes has 3 surrounding squares. So if I wanted to make a statement about what picture 10 might look like, for example, it would be my beginning dot with 10 surrounding boxes of these 4 corner dots in that square shape. Obviously, drawing picture 10 does not sound like fun, so I'm not going to do that. And we'll talk about why in a little while. Another way to visualize this is still starting at the beginning with my center dot. So my center dot is going to carry through. But instead of thinking of this in squares, I'm going to think about each corner as its own piece. This one's going to kind of look a little bit more like a flower. So my next picture, if I want to think about 3 minutes, I'm going to have my center dot, and then each petal, so to speak, is going to have 3 dots in that corner petal. So I have my center dot, this petal has 3 dots, this petal has 3 dots, that petal has 3 dots, and that petal has 3 dots as well. So this would be 3 minutes. So if I'm going to talk about a verbal description for this way of thinking, I would say I have my center dot, with, now at 1 minute, each petal had 1 dot. At 2 minutes, each petal had 2 dots. So I'm going to represent this thinking in 2 different ways verbally. So I have a center dot with diagonal petals, and those petals are growing. And actually, I should say that there are 4 diagonal petals, and they're growing by 1 dot each minute. If I want to jazz that up a little bit, my center dot has 4 diagonal groups with the number of dots for that minute. So if I was going to, again, think about picture 10, I would have a center dot and then 4 diagonal groups that have 10 dots in each group. So those are 2 ways of representing our thinking in terms of the picture and how to explain our visualization of that picture in words. I'm going to come back to these 2 different visualizations and the words when we get to our equation. But what I'm going to do right now is I'm going to look at a table. So I already have my table set up, but I'm going to talk about why I have time on the left and number of dots on the right. If you think about when we talked about functions, I have an input and an output. I have an independent and a dependent variable. The independent variable is going to keep traveling on no matter what is happening. The way that I always think about it is if I'm dealing with time, nothing is going to affect how time is progressing. Time will be my independent variable. The number of dots is going to depend on what minute we are looking at. So since I have beginning and then 1 minute, 2 minutes, 3 minutes, my starting time in this case is 0 minutes. And I'm just going to put above this minutes so that there's no confusion. So at 0 minutes, I had 1 dot. At 1 minute, I had 5 dots. At 2 minutes, if you count all those dots up, there will be 9 dots. And since I have my third picture, if you add all of those dots up at 3 minutes, we'll have 13 dots. And there's a couple of things that I want to look at in this table. Now, when we looked at our picture, we documented how we saw the growth happening. I can do the same thing in a table. It'll just look a little bit different. These time values, I see that they are going up by 1. I'm always increasing by 1. That's consistent, which is good. That's super helpful. Along the dependent, or the number of dots, every time I go up 1 minute, I have added 4 more dots. Regardless of if you saw it as the squares or the flower petals, I'm adding 4 more dots every time. So all the way down my table, I'm adding 4 dots. So if I wanted to, without drawing a picture, I could figure out how many dots I would see at 4 minutes. And I can do that by taking 13 and adding 4. Hopefully in your brain, you got 17. So I'm going to come back to my table after I make some graphs, because I'm going to use my table and my visual representations to help me create equations. So I already have some graphs built here, and I have 2 axes drawn because I want to look at this graph in 2 different ways. So if I look at this as a series of points, at 0 minutes, I had 1 dot, so I'm going to put a point there. At 1 minute, I had 5 dots, so I'm going to put a point here. Now, I counted by 2s only because I made my graph a little bit smaller. At 2 minutes, I had 9. At 3 minutes, I had 13. And at 4 minutes, I had 17. A lot of times when we create a graph like this, our initial instinct is to connect all the dots. And sometimes that's okay to do. But my question to you now, if I connected all these dots, that would tell me that I could figure out at 27 seconds how many dots I would have in a picture. But we don't actually know if all of these dots show up right at 1 minute, if they show up every 15 seconds. We don't actually have any information other than what happens at 0 minutes and what the picture looks like at 1 minute. This is a scenario, as hard as it's going to be to just leave it like this, this is a scenario where I actually do not connect the dots because I don't have any information other than those specific minutes in time. This graph is called a discrete graph, and that means it's just a series of points. I know that when you were in middle school, you would sometimes do bar graphs. You can also do a bar graph for this. I didn't really label my axes well enough for that, but we're just going to go with it. So I'm going to label this time 0. This is going to be time 1. This is going to be time 2. I'm going to have each box be my minute. So at 0 minutes, I have 1 dot. At 1 minute, I had 5 dots. At 2 minutes, I had 9, and so on. I apologize for the absolute train wreck that my x-axis is, but this is 0 minutes, 1 minute, 2 minute, and so on. So even though I have two drastically different graphing representations, I can still find that adding 4 pattern by looking at my graph. So I know that my time in minutes is increasing by 1. Well, how can I represent that on the graph? Well, I've moved over 1 space in time, and then my dot has vertically moved up 4. And if I repeat this, I can see that every time I move to the next minute, that adding 4 dots is represented in that vertical jump between dots. At this point, I'm going to go ahead and just give you some terminology. This +4 change that we're seeing consistently is called a common difference. What that tells me is that regardless of what piece of the table or the graph or the pictures that I'm looking at, I know every time I move up 1 minute, this common difference of +4 is always going to be my pattern. And I'll give you an overarching title for this type of data that we're looking at in a little while. Speaking of that common difference and seeing that +4, I can still see that in this graph because that pink highlight in there is the difference between 1 minute and 2 minutes, and it happens to be 4. Same thing here, and I can do the same thing again for 4 minutes. I have my stack from before, so if I was going to color this in, this would be my 0 minutes. And then I stack 4 pink ones on top, and that represents that +4. So here I see the +4, here I see the +4, and then in the pink I see the +4. So regardless of what type of graph you may have drawn, you can still see that common difference, that adding 4 pattern happening in these dots. So I'm going to go back to this first picture, and I'm going to look at my table and my picture at the same time, and we're going to try to work on building an equation. So I'm going to create another table because I like to have some working space. And I'm going to label this T and D for time and dots. So I'm going to have 0, 1, 2, 3. And then this was 1 dot, 5 dots, 9 dots, 13 dots. So what I'm going to do at this point is I am going to label what's happening in my picture in my table as well. And instead of doing a +4 like this vertically, I'm going to actually write out what I've been adding step by step. And we're going to see if that helps our brain spark any ideas as to how we might write ourselves an equation. So I'm going to match my colors to where I'm going in my picture, just to help your brain connect the picture and the table and the math that's happening. So my 1 dot, nothing happened there. That's just my 1 dot. To get from my center dot to 5 dots at 1 minute, I added 4 dots in a square around the outside. For 9, I started with my center dot. I added my 4 blue dots in a square. And then I added my 4 pink dots. And you might start to see some type of pattern happening here. So I have my 1 dot that was in the center, plus my 4 blue dots in the square, plus my 4 pink dots in the square, and my 4 green dots in a square. So what we are going to work on creating right now is an equation that relates what's happening over here to whatever minute we're actually looking at. So this 1 has always been consistent. It's always there in the center. Since that dot is consistent, the minute is not going to affect it in any way, shape, or form. So I know when I'm working on, let's say I wanted to figure out picture 10. Well, I would have my 1 dot in the center, and then I'd have to figure out how many squares of 4 corner dots I would see around that center dot. Well, as we talked about when we were creating our picture, the center dot has squares of 4 dots that are surrounding it, and the number of surrounding squares is the number of minutes that have gone by. So what that's telling me is the number of +4s I see here relates to the number of squares that I see. And the number of squares I should have is whatever minute I'm looking at. So that tells me, regardless of what minute we're looking at, the number of 4s or the number of squares that I've added is actually whatever time we're at. So if I wanted to figure out minute 100, well, I would take my center dot. I would have 100 squares of 4 dots around it. So I would do 4 times 100 plus 1. So at 100 minutes, I should have 401 dots. That does not seem like a fun picture that we would have to draw. So this is going to be how I find my number of dots. I would use this type of formula if I was talking about 100 minutes or 200 minutes, or maybe even 20 or 50 minutes, because those pictures would be very big if we wanted to draw them. Not fun. And if I only had up to picture 3, I wouldn't want to add 4 however many times I needed to get up to one of those larger numbers. This type of formula is called an explicit formula. And I use an explicit formula if the input number I've been given is much larger than or far away from the input numbers that I currently have. But if I wanted to find 5 minutes, it's very close to what I have over here. All I would have to do is add 4 to 17, and I would have my next number of dots. And I can actually write an equation for that as well. It's a different type of formula. It's not called explicit, but it's representing of this repetitive process that I'm doing over and over again as I move down the table. For now, we're just going to do words with it. So, oh, sorry, tilted it sideways. Let's say I'm looking for 5. I'm going to call this my next output. Because that's what I'm doing when I'm doing this repetitive process. I'm taking the output value I have from right now, and I'm working on getting to the one that I need next. This is where I am right now. Well, if I wanted to find time 5, I would take 17, where I am right now. I would add 4, and that gives me the next one. And that's exactly how I write this formula. The next output that I'm looking for is equal to the one that I have right now plus 4. And that repetitive process we're doing over and over again is called recursion. So this is recursive. That's the name of this formula. It is a process that I do over and over again. And the key thing to take away here is this is only when I'm doing output values. They tell me what time I'm looking for, but then I don't deal with time anymore. I'm only using output values here. Explicit, though, I'm actually using my input value to find my output. So this is an input and an output. This is an output and an output. That's one of the biggest differences between recursive and explicit. But even in those formulas, I still see my common difference pattern. So everything that we just did with the picture, the words, the tables, the graphs, and the formulas, all of this is under the overarching title of arithmetic sequences. Sorry, can't see that, can you? So an arithmetic sequence, the way that we find that is if I'm looking at a picture, a table, an equation, a graph, what I'm seeing is that common difference. So this is a constant pattern of addition, or it could be subtraction. since that is the opposite of addition.